So here are the current assignments. Tonight is due section 3.1, 32 and 34. Tonight 9 p.m. as usual. And web assignment for sections 3.1 and 3.2. That's due on Thursday. As is. Oh yeah, and then this. Did anyone have problems finding the focus? By the way, uh, I guess it's on page 273 in the book, right? 273 to 280. But if you're using the ebook, this is at the end of chapter 2. Did anyone else have trouble finding that in the ebook? So let me show you. If you go to the ebook, um, so the ebook on WebAssign, there may be other formats for the ebook, but if you're using this one, right, here's the link for the ebook. If you go to, come on, if you go to chapter 2, took me right to it. Let me see. Yeah, if you click on this right here, yeah, chapter 2, and then if you click on that, I don't know, table of contents icon right up here, it takes you to this. The table of contents for chapter 2. Focus on modeling is right here. Right, so here's that stuff that we've been talking about, and the problem to hand in is over here, number 24. Okay. I mean, actually, you know what? I'm just gonna copy it, and stick it right here. So here, you don't even have to go and look around for it. There's the problem right there. So there's number 24. Okay, so well, that's due on Wednesday, tomorrow, and section 3.2 Thursday. All right. um, so last time we went over section 3.2. We went over the lecture for that, and so today let's do some discussion problems there. Oh yeah, I wanted to say. Uh, Section 3.3, which we'll talk about today, there's no discussion problems on the syllabus. Um, so we'll do these. All right, so 3 through 23 odd. So when we get to that later today. And right, you should have received your graded not final exam, second exam, Friday, I think it was. Solutions are posted right here. Um, So, take a look at the solution, see where you went wrong. Number 8 wasn't graded, unfortunately. I made a typo on the exam. It said T in minutes when it was supposed to be seconds, and, that caused confusion. So it was supposed to be seconds, and here's what the solution looks like. So everyone just got full credit on that one. And, see where you went wrong on the other problems, on that one as well. The final exam, I'm just going to take problems from the 3 midterm exams and just, make it from that. Not the same problems, of course, but things very similar to it. The results on exam 2 were quite bad. Not sure what to what to say about that. Y'all are paying to be here, or somebody else paid for you to be here. I'm here to help, so but I can't insert the material into your mind. You got to put pencil to paper and do the practice on your own. I mean, I'm guiding you in how to practice, but you actually have to put the pencil to paper and do it. Okay, so hopefully we can do better. Okay. All right. So section 3.3. On the syllabus, we've got, or not 3.3, 3.2. On the syllabus, we've got 9 to 42 every third problem. So, we were talking about graphing polynomial functions. Number 22, let's take a look at, or not 22, every third problem. Number 21. So we have a polynomial function, p of x, equal to x plus 2, x plus 1, x minus 2, x minus 3. Okay, let's sketch the graph. Y equals p of x. Okay, so the assumptions we make about the graph is that it's smooth and unbroken, right? And each end of the graph either goes to plus infinity or minus infinity. So smooth and unbroken, and approaches plus infinity and minus infinity. So smooth meaning it's not kinked ever, there's never a corner. It is smooth and unbroken. Continuous is the term for unbroken, the fancy term. So this doesn't happen. And the ends of y equals p of x go to infinity, plus or minus infinity. And how do you know when it's plus or minus? Well, we do this analysis of the function as being positive or negative as follows. So y equals p of x is 0 at 2, 3, -1, and -2. So -2, -1, 2, and 3. So we've got these intervals defined by, where the function y equals p of x is 0. So p of x equals 0 at x equal to -2, -1, 2, and 3. So now we've got these intervals, and you check the intervals to see whether the function is positive or negative on those given intervals. And that will be enough information to get a decent sketch of the graph. So pick a value inside each interval. So this one, x equal to -3, say. Right? This is negative, 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 negative. So it's 4 negatives. 2, 3, 4. So it's positive. So we're positive in this interval. Between here and here, x equal to -1.5. So this one is positive, and then these are all negative. So positive times 3 negatives is negative. And from -1 to 2, say x equal to 0, positive, positive, negative, negative. All right, so we're positive in here because that product is positive. And between 2 and 3, x equal to 2.5. So these 3 are positive, that one's negative. So we're negative here. And then in this interval, check x equal to 4. All 4 of those factors are positive, so the function itself is positive, the product of those 4 factors. All right, so we know where the graph is positive or negative, and we know where the graph is 0, and we've got these two assumptions about how it behaves. So we plot these 0 points on the x-axis. So -2, -1, and then 2 and 3. So -2, -1. So the graph goes through this point, -2, -1, and then 2 and 3. And then also, if you want, you could also maybe plot the y-intercept. Might be nice to know that. The y-intercept is p of 0. So that's 2 times 1 times -2 times -3. So what do we have here? So it's positive 6 times 2 is 12. So it's up here somewhere, 12. All right, so now we know, if you want, you can put those positives and negatives here as a guide. Positive, negative, positive, negative, positive, positive, negative, positive, negative. Oh, no, that's not one of the intervals. This whole thing here is positive. So positive, negative, negative, and then positive here. So it would look something like that. Oh, it's got to go up here, sorry. Come on. There we go. So something of that sort. Okay, it shows where the function is 0, and it shows where it's positive and negative, and it shows that it's going off to infinity in both directions. Positive infinity in both directions for this function. It could be that one is positive infinity, one is negative infinity, both are positive infinity, or both are negative infinity. It will tell you when you do this positive negative analysis here. Okay, so that is number 21. If you want, we can, get an actual picture. Looks like to see how close we are. Well, not an actual picture, but a more accurate picture. So graph y equals, so what was it? X plus 2, x plus 1. X minus 2, x minus 3. Right? So there's a more accurate picture of what it looks like. Our methods don't give us, these details. The one detail that we would really like, that is missing is where these local maximums and minimums are, right? I mean, the function is negative and then it becomes positive, so it has to, curve down and then come back up. So you're going to get these relative maximums and minimums. Like I mistakenly put the maximum here at 12. It's not there. Right? It's not at that spot. Where is it? Well, it's here somewhere. Not sure where that is. X equal to a half, maybe. Right? But you need calculus to find those points. Except with a parabola. We know how to find that point with just a parabola. We know how to find it algebraically. One more example. That was 21. How about number... So I gave you number 38 to do, or I give you 26. How about, so something like 26. Number 25, well, that's not a third problem. Let's do 25. So 25 is sketch the graph y equals, and this one looks like, so we got x plus 2, x plus 1 squared, 2x minus 3. Right, so y is equal to 0 when x is equal to negative 2, negative 1, and 3/2. So put those numbers on the line. So negative 2, negative 1, and then 3/2. And, check for positive and negative behavior. So here, x equal to negative 3, say. This is negative. This is negative, but it gets squared, right? So a negative number squared, of course, is positive, and then sticking x equal to negative 3 in here, that's negative as well. So the whole thing is positive. Between here and here, x equal to negative 1.5, x plus 2, so negative 1.5 is positive. Positive 0.5 squared is positive. And here, plugging in negative 1, that one is negative. So positive times negative is negative. Between negative 1 and 3/2, x equal to 0. Positive, positive, negative. So it's negative here. And bigger than 3/2, x equal to 2. They're all positive. So the function is positive here. So we get the following picture. A rough idea of what this function looks like. Negative 3, or no, we're using negative 2. Negative 2, -1, 1, 2. So 3/2 is right there. Right, so positive, negative, negative, positive, and it says 0 at these points. We could also find the y-intercept. It'd be nice maybe to have that point. So when x is equal to 0, so x equal to 0, you get y equal to 2 times 1 times -3. So that is equal to -6. So these are the x-intercepts. That's the y-intercept. So positive, positive, negative, 0. So this one we actually do know is a local maximum, right? It's positive and then negative after you get past the 2. And then it's got to be 0 here, and then it's negative after that. Right, so that one we actually know is a local maximum, right? And it's got to be negative again. So negative and negative on each side of that, but it's 0 here. So that's got to be a local maximum. So something like this. And probably this point is not the local minimum. You can actually get a better idea what that looks like. So x plus 2, x plus 1 squared. And then 2x minus 3. Oh, so the relative it's way down here. So I'm pretty far off. But I mean, again, that's all we really can tell, unless you like make a table of values and get some idea what the numbers there look like. So actually, I want to change that a little bit to look like that a little more. But again, we can't know exactly where that's happening. So just, this rough sketch of what the thing looks like is the best we can do at this point. By the way, since we've got all these nice computing tools and graphing calculators, you may ask me, well, what's the point of the exercise if we can just graph the thing? The point of this exercise, or these exercises, really is trying to understand the nature of functions and how they work and why the graphs look the way they do. Not just to get the picture of a graph. Is to explore the meaning of these things, of these pictures. And what our knowledge of algebra and tells us about geometry, and what geometry tells us about the algebra. And in order to do that, you got to go through these thought experiments, these exercises. Okay, so I mean, again, the goal is understanding. The goal is not, just to get a picture. Or maybe you weren't thinking that. But anyway, if you were, that's the point. All right, and then number 38. So like number 38 is 39. So this one was like number 26. And then like number 38 would be 39. So sketch the graph. 2x to the third minus x squared. minus 18x plus 9. So factor the polynomial first. So in order to do this, we first must factor the polynomial. Okay, so it's a polynomial of degree 3, and that's got a non-zero constant term. The only way we know how to factor such a polynomial of degree 3 was that, that grouping terms stuff. Grouping terms, the first two terms and the last two terms together. And you factor out common factors. Again, there's not too many polynomials where that works. Degree 3 polynomials where that works, but since that's the only technique we know at this point, it's going to work here, unless you don't need to factor it. So to do that, right, if you forgot how that goes, this is it. So let's do it this way. The first two terms, you have a common factor of x squared. So it's always going to be x squared times a constant. And then you're left with 2x minus 1. And then in this, you've got a factor of, let's take minus 9. And you're left with 2x minus 1, not plus 1, minus 1, right? And when those two grouped terms, when you factor the two grouped terms, if you're left with another common factor like that, and that's when this technique works, then you can factor that out again. 2x minus 1, x squared minus 9. So that's 2x minus 1, and then this is the difference of two squares. Like that. Right, so first factor the polynomial fully into linear factors. And then graph as usual. Okay, so finish as in the previous two examples. All right. Okay. So that's a good selection of problems there. Again, I'm gonna say it. I know some of you are doing it, but I know most of you are not. The practice problems that are given on the syllabus, those are problems that you need to do to practice the material in order to sort of work your way up to doing the homework problems, which are typically problems that are a little bit more difficult among the practice problems. And then to get ready for the exam. It's simply a matter of practice at this level. Learning mathematics at this level is simply a matter of practice. Okay, and getting help when you need it. Practicing and practicing the right way. So just drill and repetition, guys. That's not a huge secret. It's just what you need to do at this level. If you're trying to do that and you're not succeeding, that's when you need to come and see me. Okay, and then we can go further from there. All right. So on to section 3.3. Again, for section 3.3, I've got these practice problems here because we don't have any on the syllabus. There is a, sort of this little supplementary handout. I have it, but I'm not like I'm not like too happy with it. I think we really need to do these problems and in section 3.3 and and practice the the techniques involved. All right, so in section 3.3, it's on division of polynomials. And this is important because a lot of nice examples that you deal with in this course and in calculus are with rational functions. Rational functions are polynomial divided by a polynomial. And being able to do division of polynomials helps in understanding rational functions as well as just ordinary polynomials themselves. So, by the way, y'all already know how to do this. Because you all already know how to divide numbers, long division of numbers. So remember, right, how to do long division of numbers base 10, right, from grade school. I don't know, it's 4th grade or 5th grade when you learn that. The polynomial, well, numbers base 10 are just polynomials, right? They're polynomials where x is actually equal to 10. So division of polynomials is very much the same as this, because numbers base 10 are really just polynomials with x equal to 10, and just using coefficients 0, 1, 2 up to 9, the basic digits, 10 digits for base 10 arithmetic, right? If you've got 1,324,000 and 21, let me put another 0 in here. What is this? Well, this is 1 times 10 to the 6th plus 3 times 10 to the 5th plus 0 times 10 to the 4th plus 4 times 10 to the 3rd. 10 to the 3rd is 1,000, right? Plus 0 times 10 squared, which is 100. Plus 2 times 10 to the 1 plus 1 times 10 to the 0. Right? That's a lot like x to the 6th plus 3x to the 5th plus 4x to the 3rd plus 2x plus 1. Right, so numbers base 10 and polynomials are, really the same, sort of the same thing. By the way, there's other types of arithmetic if you're into, rather than just arithmetic base 10, right? In computer science and in the architecture of computers, they use arithmetic using what base? Does anyone know? Base what? Often called binary. Instead of using x equal to 10, they'd use what? X equal to... Somebody knows. X equal to 2, right? Binary arithmetic. So with x equal to 2, and then your only two digits are just 0 and 1. And, you have polynomials with just coefficients using 0 and 1, and x is always equal to 2. That's binary arithmetic. And, that's useful because it translates nicely to electronic switches, which is what computers are based upon. Switches that are either off 0, on 1. So there's base 2, and also in computer science we use base 16, often called hexadecimal. All right, so let's do some examples of how to do the polynomial division. You'll see how similar, how similar it is. So let's divide x to the third minus x squared minus 14x plus 24 by, let's say, 2x plus 3. 2x plus 3. So you do this neat little symbol here, right? And you put the thing that you're dividing, which is x to the third minus x squared, underneath this, division bracket or whatever you want to call it. And then your divisor, the thing you're dividing by, 2x plus 3, outside here. Okay, now let's go step by step. So first thing, our first term here is x to the third. And our first term here is x to the third. What do I need to multiply 2x plus 3 by to get an x to the third first? Well, that would be 1/2 x squared. If I take 1/2 x squared and I multiply it by this, what do I get? Well, I get first x to the third plus 3/2 x squared. Right, so that is, let me do it in red. So x to the third plus 3/2 x squared. So that is 1/2 x squared times 2x plus 3. All right, and now what I need to do is subtract it. Now subtract. So what I'm going to do is I'm going to take this. So I mean, you would do this all with one bracket, but I want to show it step by step in the notes. So I'm going to subtract this. So what I need to do is flip the signs. Or if you want, I could just put it right here. So negative 1/2. So the negative sign is going to be out here, right? So I multiply 1/2 x squared times 2x plus 3. And I get this. And I leave that negative sign out there. But then I need to distribute the negative sign through. Right? Take this negative sign and distribute through, and I get negative x to the third plus minus 3/2 x squared. Okay, now subtract. Right? X to the third, or add, x to the third times, or x to the third minus x to the third is 0. Right? You're trying to cancel out that first term, which is what happened. And now I've got minus x squared minus 3/2 x squared. That's minus 5/2 x squared. And then bring down the other terms. Right, so x to the third minus x to the third is 0. Minus x squared minus 3/2 x squared is minus 5/2 x squared. And then bring down these other two terms, minus 14x plus 24. Because you're just subtracting 0 from those. Okay, next step. what do I need to multiply What do I need to multiply 2x by to get negative x squared? Well, that would be negative 1/2 x. Right? 2x times negative 1/2 x gives me, what do I need to multiply 2/2 by 2x by to get minus 5/2 x squared? So that would be minus 5 over 4x. Right? Minus 5 over 4x times 2x is minus 5/2 x squared. So now I'm going to take this and multiply it by this whole polynomial. So this is minus 5/4 x times 2x plus 3. Right, so minus 5/4 x times the 2x is going to give me minus 5/2 x squared. And then minus 5/4 x times positive 3 is going to be minus 15 over 4x. Okay, now subtract. So I need to take this negative sign and distribute through here. Let me try a different example. This one, the fractions are a little getting out of hand here. Let's try a different example. Let's get rid of that 2 here. Let's just do x plus 3. So divide this by x plus 3. So again, set that bracket. X to the third minus x squared minus 14x plus 24. And x plus 3, put it right here. So I multiply x by x squared to get x to the third. So I put x squared up here, and then minus x squared times x plus 3 I put here. So this is minus x to the third plus 3x squared. Right, so if I multiply x by x squared, then I get an x to the third. So then I put the x squared up here, and I take negative x squared, multiply it by x plus 3, and put it right there. All right, so now distribute to subtract. So distributing the minus sign through here, I get minus x to the third minus 3x squared. Right, so now when I add these together, right, I multiply by negative 1 because I'm subtracting, and now I add them. The x to the third goes away. Right, x to the third minus x to the third is 0. Now I have minus x squared minus 3x squared is minus 4x squared. And then minus 14x minus 0 is minus 14x. And then 24 minus 0 is 24. So I'm just bringing down these two terms here. Now, what do I need to multiply x by to get minus 4x squared? What do I need to multiply x by to get negative 4x squared? Well, minus 4x. So now I take minus 4x and multiply by x plus 3. Minus 4x multiplied by x plus 3, and I'm going to subtract that, so there's a negative sign here. So it's negative, and then multiplying these two together, I get minus 4x squared minus 12x. All right, now distribute the negative. To subtract. So this becomes positive 4x squared, positive 12x. Right, so now the 4x squared is going to go away. Minus 4x squared plus 4x squared is 0. Minus 14x plus 12x is minus 2x, and then bring down the 24. Okay, now what do I need to multiply x by to get negative 2x? Well, I would multiply by just negative 2. Okay, I would multiply x by negative 2 to get negative 2x. So I'm going to multiply negative 2 times x plus 3, and I'm going to subtract that. So I'm going to put a negative out front. So I put that here. So this is the negative of negative 2x minus 6. And now we're going to distribute to subtract. So distributing this negative sign through here, I get 2x plus 6. Add these two together, the x's go away, right? Minus 2x plus 2x is 0, and I have 24 plus 6 is 30. Okay, now what's left here? At this point, we're done. Now what does this mean? So this is a polynomial of degree 0. This is a polynomial of degree 1. When this result here has degree less than the result here, you're done. When the degree of the remainder, which is this number here, is less, strictly less, than the degree of the divisor, you're done. Okay, so what is this here? What does this tell you? So this right here is the remainder, and this right here is the quotient. Okay, so we say is that x to the third minus 2 or minus x squared minus 14x plus 24 divided by x plus 3 is equal to the quotient x squared minus 4x minus 2 plus the remainder over x plus 3. Right? So x to the third minus x squared minus 14x plus 24 divided by x plus 3 is equal to this quotient, which is what we found here, x squared minus 4x minus 2, plus the remainder, which is 30, divided by that x plus 3 still. Right? Just like how we write so this is like writing so when we have, say, 18 over 5, what do we write? We write 3, well, maybe I shouldn't use that, 19 over 5, 3 plus 4/5. I know we usually write it like this, okay, but that's, that has a double meaning. That's a shorthand notation. Shorthand notation that's used in, in carpentry and in cookbooks and all that sort of thing. But, this actually means 12/5 in mathematics. That's multiplication, not addition. What it really is this, 3 plus 4/5. So when we say 3 and 4/5, we mean 3 plus 4/5. So this is like writing 19 over 5 equal to the quotient, which is 3, because 5 goes into 19 3 times, with 4 left over. 3 plus 4 left over divided by 5 still. So that's exactly what we do here. This polynomial divided by x plus 3 is this quotient plus the remainder over x plus 3. All right, let's try a different example. Let's try that same polynomial. X to the third minus x squared minus 14x plus 24 by, let's say, x squared plus 2x plus 1. Okay, so let's do it all with one bracket. So rather than going like, step by step and rewriting the bracket every time, let's do it all just in one go. So x squared plus 2x plus 1 divided into x to the third minus x squared minus 14x plus 24. What do I need to multiply that leading term, x squared, by to get x to the third? Well, just x. So now I'm going to multiply x by this here. So x times x squared plus 2x plus 1 is x to the third plus 2x squared plus x. And I'm going to subtract that. Okay, I'm going to subtract that. Okay, first I multiply this by this, and I just write it down right here, and notice these two match. Now I need to subtract it, so what I do is I just flip the signs here. Right, it was positive x to the third plus 2x squared plus x. But now I'm going to flip the signs and make them all negative. I'm going to just negate each term. Flip the signs on each term. And now I'm going to add. So x to the third minus x to the third is 0. X squared minus 2x squared is minus 3x squared. 14x minus 15x. 24 minus 0 is just 24, bringing down that last term. Now, what do I need to multiply x squared by to get minus 3x squared? Well, just minus 3. X squared multiplied by minus 3 gives me minus 3x squared. So I'm going to write that down here. So minus 3x squared minus 6x minus 3. But I need to subtract that. All right, so first I'm just going to write down that product. Minus 3 times this x squared plus 2x plus 1 gives me minus 3x squared minus 6x minus 3. Now I'm going to negate each term. Flip the sign on each term. And now perform this addition. Minus 3x squared plus 3x squared is 0. Right? So each time this remainder goes down in degree by 1. Right? This is x to the third. This is x squared. And each time we cancel out that first term. So here we're canceling out the x squared term. Minus 15x plus 6x is minus 9x. 24 plus 3 is 27. So now this is the remainder. Has degree 1. This has degree 1. This has degree 2. You are done when the remainder, you are done at the step where the remainder has degree less, strictly less than the degree of the divisor. So what we get in the end here is that x to the third minus x squared minus 14x plus 24 divided by x squared plus 2x plus 1 is equal to the quotient, which is x minus 3, plus the remainder, minus 9x plus 27, divided by the divisor, x squared plus 2x plus 1. So that's your final answer right there. Again, this is a lot like, long division of just numbers base 10. I think actually when you try this, you'll see actually that's a little bit easier because it doesn't have that funny carrying step, right? So you have this sort of carrying ones from other digits ahead, and and adding them to the carrying and subtracting when you're adding and subtracting doesn't happen here, right? So that makes this a little easier. All right. Another example. So in this example, well, let's talk about the following. When a remainder of 0 is obtained, we get the following. So if you have p of x divided by d of x is equal to just q of x, right? P of x divided by d of x is equal to q of x with a 0 remainder. Well, that's just 0. So you get p of x over d of x divided by d of x is equal to q of x. So p of x is going to be equal to q of x times d of x. So this will be a partial or full factorization of p of x when you get a remainder of 0. So another example here. Let's use that same polynomial. So x to the third minus x squared minus 14x plus 24. And let's divide by x minus 3. So let's do this division here. Oh, it's 1055. Let me just finish this real quick. So multiply by x squared. So I have x to the third minus 3x squared. Flip the signs. So this is 2x squared minus 14x plus 24. So multiply by 2x. So 2x squared minus 6x. Flip the signs. And we get minus 8x plus 24. Multiply by minus 8. So minus 8x plus 24. Flip the signs, and that's going to give you 0. Right? So this polynomial, x to the third minus x squared minus 14x plus 24 is equal to the divided by x minus 3 is equal to just that quotient, right, with a 0 remainder. So this tells us x to the third minus x squared minus 14x plus 24 is equal to x squared plus 2x minus 8 times x minus 3. So this is a partial factorization. And because it's degree 3, we can get a full factorization now. Because we know how to factor this. This is x minus 4 times x plus 2. Right, full factorization. So we were able to factor this degree 3 polynomial without using that grouping technique. Actually, the grouping technique doesn't work on that one. Because in the grouping technique, you're always going to get x minus a times x plus a in the factorization. But that doesn't happen here. We don't have x minus 4, x plus 4, x plus 2, x minus 2, and x3 or x minus 3 times x plus 3. They're all three, distinct linear factors like that. Okay? So that's pretty much it for this section, but we'll do a couple more examples of this tomorrow. Okay? All right, have a good day, everybody. I'll see you tomorrow.